at your leisure. All right, welcome to another Gazebo community meeting. As usual, please add your name to the attendees list if you so desire, so we can keep track of who's coming to these wonderful events. We'll start off with a couple of announcements. The big one is this is the Gazebo garden release. So we have all of the release binaries rolled out for you starting now. So you can actually go and download and start running Gazebo. Gazebo Garden, you can start doing it now, or you can pay attention to this presentation, depending on if you can multitask or not. Along the way, we had a nice tutorial party to review various aspects of Gazebo Garden. This ran the gamut of looking at tutorials and example worlds and plugins and all the good stuff that we expect people to use. We ran through 334 of these tickets, and we had a number of contributors from outside Open Robotics, which was great to see. I think I saw a few of you join, and a special thanks. We are sending out t-shirts to those people, so stay tuned. They should arrive in your mailbox relatively soon. Speaking of swag, there is swag available right now with the wonderful Gazebo Garden logo on it, everything from t-shirts to baby onesies, depending on the people in your life. It looks good on everybody. All right, moving on to some more important information. People who have been paying attention may have noticed that the website, the documentation website, got a little bit of an overhaul. Hopefully this will make it a little bit easier for people to find useful information regarding how to install Gazebo to using it. As usual, if you notice anything, hit us up in the usual spots on issue trackers or otherwise, and we'll try to fix things. This all came about because we did a big renaming from Ignition to Gazebo. There's information about why we did this on the website. I won't go into the why unless someone raises their hand and wants a little spiel on that. The important aspect is that most of our configs, logs, assets, and all the goodies that kind of tell Gazebo how to run are now in a .gazebo folder in your home folder instead of a .ignition. So this can be important if you have downloaded lots of fuel assets. You may end up with duplicates in 2 locations. This is kind of like a little heads up in case you are wondering why your home folder is consuming more disk space than usual. So check out both of those locations. And on that note, I will also move on to the next important item of business, which is Gazebo H. So we are rolling out Garden, but that's boring. We need to work on the next release. And after 102 votes, we have picked a new name for the Gazebo H release, which is Gazebo Harmonic. Yay. This is related to the golden rule, the golden proportions. So this is a common design principle in architecture. So it fits well within the naming scheme of Gazebo related to architecture themes. And so everything in Gazebo Harmonic will be built around the golden principle. I'm joking. Didn't mean to undo that. So Gazebo Harmonic will come out around this time next year. You'll be able to find information about plans and roadmap items on our website that will come live, and be updated after the Garden release. So I'll stop here. If there's any questions, feel free to speak up right now, raise your hand or otherwise. If I don't hear anything, we'll move on to the presentations. There'll be more opportunities to ask questions later. All right, I don't see anything or hear anything, so I'll move on to meat of this presentation, this meeting, which is about the garden release itself. So let me switch windows here. We will have a number of people talking about various features and new capabilities in Gazebo Garden once this actually starts running. There we go. So let's have Althone start talking about what we're looking at here. Take it away, Althone.
Hey guys, thanks. This is our garden demo world. Right now it doesn't look like a garden, but we'll get there. Initially, it was between Luis and Cole and I to talk about the environment, to show the demo world. And we landed on, because it needs to have the lunar moon terrain and also a garden. So we landed on, I don't know, why not both meme. And so right now you'll see the lunar terrain height map. We're using the lunar terrain height map. And it uses the real data from NASA. Thank you, Cole, for the contribution. And it uses the data is gathered using the Lunar Reconnaissance Orbiter camera and a laser altimeter. You can get this data straight from the usgs.gov. I'm told the website's a little hard to navigate. And once you get that, you need a software called the QGIS or QGIS to convert that data to a usable height map for the terrain. And onto the garden world. So the lunar base is inspired by a lot. It's made basically from scratch and inspired by a lot of sci-fi shows like The Expanse and the images from the ISS. Most of the textures and 3D models are made from scratch using Blender and Substance Designer and Painter for the foliage models you see there from grass and leaves are straight from open license sites such as Polyhaven and Ambient CG. And that's about it.
Great, thanks, Althone. We'll move right on to Brandon, who's going to talk a little bit about the Gazebo to Ignition renaming.
Hi everyone. So as you know, we've changed the name from Ignition to Gazebo. So this means that most. Sorry, can you hear the garden?
It's a garden sound effects. Yeah.
I'm just gonna power through it. So yeah, as you know, the usages in the code will change from Ignition to GZ, and from Gazebo to Sim. So you can see on the top left-hand corner of the window, Ignition Gazebo is now Gazebo Sim. Most of these changes will be TikTok in the code, and they will normally automatically redirect you. And they will also emit deprecation warnings to help you with migration if you need them. I'll just note that the TikToks will stop being supported after Garden. So please refer to the migration guide on the website for some helpful pointers and some regex expressions to help with the migration. And I'm done. Thanks, everyone.
All right, thanks, Brendan. Let's move right on to Ian, who's going to talk about some new visualization capabilities and custom shaders.
Hi, everyone. So one of the new features that we added to Garden is support for custom shaders. We added this year. We actually added it to Fortress, and then we forward put it to Garden, so it's available in both versions. So the feature is available through a visual plugin in Gazebo. So you can use this plugin to specify the vertex shader and a fragment shader that you like to use. For example, the flag that you see here, we use the vertex shaders to deform the vertices. And then we're able to use the fragment shader to set the texture and apply simple lighting to it. In this case, we just grabbed the Gazebo logo and we map it onto the surface of the flag pole here. Mm-hmm. All right, and next. All right, and you can see here we also have a lake inside the dome. This is also done through custom shaders. These shaders are taken from Gazebo Classic. You may have also seen waves being presented in our one of the previous community meetings some months ago by Reese. So this is the shaders contributed by him. You can see this used in other maritime projects like the UAV simulator or VRX, for example. And here we just tweak the waves to be smaller amplitude, so and more calm, and we move it in the direction where the fans are blowing here. All right, I'm done.
Great. Thanks, Ian. Let's move on to Mitch, who will talk about aspects of wind.
Thanks, Nate. Hi, everyone. So local wind effects are a simple extension to the global uniform wind effects that were already available in Fortress. In Garden, now we can specify a functional dependency on space for the wind force approximation that these wind effects perform using polynomials and axis-aligned half spaces so that you can have piecewise fields. It is important to point out, though, that wind effects remain just a useful approximation, as in fluid dynamics are not being modeled. Still, it is quite handy, and it was actually motivated by maritime robotic simulation projects that need to model wind above sea level only. In this case, though, the feature is used to model an airstream, the airstream that comes out of the fan, strong enough to keep the sphere suspended at a height.
And I've been told that I can move this.
You should be able, yeah.
And I can. Oh yeah, there it goes. All right. Well, and I've gone outside of the sphere. All right. Thanks, Mitch. Let's move on to the Reset API. Michael, take it away.
Yeah, so another feature that we have added in Gazebo Garden is the ability to reset a running simulation. This is a feature that was in Gazebo Classic, but it's been updated for the current release of Gazebo. And so basically what this allows is for simulation to reset without having to reload all of the assets, which can be quite kind of costly, and it can take a long time for the entire simulator to reset. So this could be useful in cases where you want to kind of explore parameter space or iterate kind of rapidly on a controller in your simulation. This also adds an additional interface that developers can use for systems to implement custom reset behavior. For more information, you can check out the pull request that originally merged it in the GZSim repository.
Great, thanks, Michael. And as you may have seen, I've been resetting via the service call, and I believe there's a PR coming out that will have a button as well if you want to reset it on the GUI. Okay, and I have been resetting this nice looking model, which I believe Adisu is going to talk about.
Thanks, Nate. Hi, everyone. So this model is actually imported from Mujoko. So it used to be an MJCF file. And I want to talk about what we've been working on in the last few months, and that is the ability to go back and forth between MJCF files and SD format. And so we will share slides now. This is a new package. It's a Python package for converting from SD format to MJCF and vice versa. It uses Python bindings for SD format and GZMath. And at least for SD format, that is something new in Garden. And you can find out more about that in the URL, the GitHub URL below. And so it's actually pretty simple to install. It's available on PyPI, the Python package index. With Garden installed, you just do pip install SD format -mjcf, and it should install all the dependencies, including DM control. And so then after that, you can run SDF to MJCF and give it an SDF file, and you give it an output directory. It's an output directory because whatever is included in the .sdf file, like textures, assets, textures, meshes, etc., will have to go all into this directory. And so you want it to be contained in one directory, and that's what that does. And so here we're showing the Panda arm taken from the fuel, and you can see how they're behaving quite similarly. Gazebo on the left and Mujoko on the right. It's not quite the same visually because Gazebo supports physically based rendering, or PBR, and Mujoko doesn't support that at the moment. But that's just there will be some differences in visualization or some behavior, but overall they behave very similarly. The slight modifications we've done for the Panda arm is change the you have to download it directly from the website instead of from the command line because it will contain relative paths to the meshes instead of fuel URIs. Fuel URIs are not supported in the conversion. In this slide, we're showing going from Mujoko or MJCF to Gazebo, and it's very similar. The command is MJCF2 SDF, and you give it the XML file and the output directory. And again, they kind of behave very similarly, but you can see differences. The ground texture is different in Mujoko because they have the ability to generate textures like that on the fly. Gazebo doesn't have that. And then the lighting is different. As you could see in Mujoko, there's a way to set a light to target a model, and in Gazebo, you have to attach it to the model, and it kind of moves with the model. So some of these are some of the differences you'll see, but there are more. You can find out more about the limitation and differences in that GitHub page I mentioned. But otherwise, this is available, and you can go ahead and try it and let us know what you think. Thanks.
Great. Thanks, Adisu. Let's move on to DEMs. Take it away, Jen.
Thanks. Hi, everyone. So from Fortress, we have height map support using 2D images. Now from Garden, we've added support for DEM files, which stands for Digital Elevation Models. And this was ported over from Gazebo Classic. For best performance, the DEM should be square. And to quickly summarize what DEMs are, they're files that encode height information of the terrain where each point or pixel contains an elevation value. We've added 3 example worlds for you to try out. We have Mount St. Helens volcano in Washington, and Monterey Bay here in California, and another one of the Earth's moon.
So in Gazebo Garden, we recently added support for custom surfaces and celestial bodies in spherical coordinates. So what this means is the spherical coordinates tag now supports moon_SCS, that is selenographic coordinate system, and custom surfaces as surface types, which originally default to Earth. These can be used when you load non-Earth DEM models. So let's say moon or theoretically even Mars. So what this does internally is calculate the sizes and coordinate transformations accurately based on the geometry of the celestial body. To use this, you can simply add moon_SCS as a surface model inside spherical coordinates, or equivalently use a custom surface and supply the equatorial and polar axis. You can find an example called DM_moon to demonstrate this. I'll move to acoustic comps. So in Gazebo Garden, we also we'll be adding a new feature related to acoustic comps. I'll start with a demo first. So in this demo, I have 3 robots stationed, and the robot on the left will send a command to the other 2 robots using acoustic comps and sound to start moving immediately. I've purposefully slowed down the speed of sound in this demo, so you can see visually that the sound takes like finite amount of time to reach the second robot, then starts moving, and then eventually it will reach the third one as well. So yeah, this, because the sound takes like appropriate time, the time for the robot to start is proportional to the distance between them. Using this plugin is really simple. So you need to add two plugins to use acoustic comp. So first one is the acoustic comp itself, where you can specify the max range and speed of sound. And for each robot, you can specify a comms endpoint, which contains the address and the topic on which the robot would listen. To use this, you simply have a publisher that publishes to a broker, and your subscriber takes the data from the broker. So in this example, I had 3 robots with addresses 1, 2, and 3. And the first one was sending commands to the other 2. Note that this is a part of a larger comms infrastructure. So it's a generalized comms infrastructure that we have. So you can theoretically even simulate Wi-Fi if you want. Note that this feature will be available in a minor release. Next is a feature called environmental lookup sensors, originally worked on by Arjo, our colleague from Singapore, and Jen will be narrating
it. Thanks. So this feature will land in a minor release of Garden. You can load the environment using the environment loader plugin. This environment is basically a CSV file with timestamps, positions, and sensor data. You can use the loader plugin to pick the CSV file. Then here you can set the time dimension and the X, Y, and Z coordinates, then select the desired reference frame. Finally, click Load, which will load the file into the simulated environment. When you run the simulation, you'll be able to see the sensor data from the vehicle based on its position. So for instance, here we have a vehicle Triton publishing the loader sensor data. You can echo the topic to see the data stream coming out, which is based on the CSV file. So to summarize, users can record data from real-world sensors, then play that data back in simulation using this environment loader plugin.
All right, thanks, Jen. Up next is Michael with static plugins.
Yeah, so another new feature that we've added that's a little less flashy, I think, than some of the other demos here today, is we have the ability to have what we're calling static plugins. So up until this point, a plugin for Gazebo has had to have been stored in its own shared library, and then you would reference that shared library in the SD format file, and it would get loaded. In contrast to that, this allows you to define your plugins and register them and statically link them into an executable. That could be the Gazebo executable if you're doing some custom development, or your own executable or test executables. So I think this is going to be pretty powerful for developers as they develop unit tests and integration tests, because you can declare your plugins in the same file as the tests and just use them from there. So a little bit for more context and kind of the origination of this, I would check out the original GZ plugin pull request down at the bottom. And then we also have an example of showing how to use this static plugin in a test in the GZSim repository. Both of those are good references for kind of the things this will enable. Another improvement with Garden is that we've migrated from Ogre 2.2 to 2.3. As we, we migrated from Ogre 2.2 to 2.3, which has a variety of other improvements from the upstream Ogre development. Most of these improvements are with performance. As a graphics library like this, as they move forward through time, it's continuously making enhancements. But there's also some improvements in the way things like shadows are handled, and more can be seen in the change log here at the bottom. This also kind of lines us up for using even newer versions of Ogre as time goes on. Part of this migration is enabling Vulkan support. And so the Vulkan rendering backend is kind of the modern alternative to OpenGL. And so it has better performance and more control, more compatibility across all platforms. Part of this from the Ogre perspective is we also had to port all of our shaders into Ogre's own language, HLSL, which means we've kind of gotten better Ogre support in terms of macOS Metal and Windows Direct 3D as part of this migration as well. Of particular interest is headless Vulkan support, which is also included as part of the larger Vulkan support. And this is ideal for container environments and cloud environments, as it can ultimately remove the entire X dependency for doing any sort of rendering work in Gazebo.
Great, thanks, Michael. Looking forward to using that in all my cloud work. Let's move on to SD format and Python bindings with Alejandro.
Thank you, Nate. Hi, everyone. So during the past month, we worked in some Python interfaces, such as GCMath and GCSim, and this time is SD format. So we have developed Python binding for this library in Python 11, which make very simple to use with the other ones. This Python binding should simplify the creation process and allow developers to automate a lot of common simulation tasks. This feature makes it possible to generate an unlimited number of models and worlds on the fly, which is incredibly useful for applications like robot testing, parameter tuning, or domain randomization. And in the next slide, you can see a very simple example about how to use this Python binding. So in the first line, you include the library, then you create a root element. We used a method inside the root element to load a file. If everything is fine, then we can modify, add new elements, and at the end, we can save all the changes in a new file or in the same file. It's up to you. So you can just write this root to string method. And if you are looking for an example, a more big example of how to use this, you can go to the SD format to NGCF GitHub repo, and you have there a very deep example about how to use it, this Python binding. And that's all from me.
Thanks, Alex. And moving on to our last presenter is Jen, who is talking about GLTF.
Thanks. So I'm presenting on behalf of our colleague Lucas from Singapore. GLTF is the latest mesh format developed by the Kronos group, and it is quickly establishing itself as the standard for mesh exchange. The format supports physically based rendering natively, so PBR assets can be exported from your favorite 3D software and imported in Gazebo without having to manually add SDF tags to specify the PBR properties. The format is made of a JSON header for ease of development and binary data for arrays for high-speed parsing. We added support for the format through the Open Asset Import Library, ASIMP. And if you can go to the next slide. Here is an example of how you have to specify PBR properties manually for a format that doesn't support them, such as Colada, which is at the top example. The bottom example shows that your model SDF would look like for the GLB format since it embeds the information. This feature also reduces the workload on 3D artists since they can import and or export without having to deal with the SDF tags. It also reduces discrepancies between the model's appearance and the artist's software of choice and Gazebo. And with that, I'm finished.
All right, thanks, Jen, and thanks to all of our presenters for highlighting some of the new features within Gazebo. I will mention that since today is the Garden release, you will notice on our roadmap that there are a number of in-progress features mentioned, such as added mass, which is useful for modeling fluid dynamics in relation to submersibles and mimic joints and improved bolt support. There's a number of items there that will be coming out in patch releases in the relatively near future. So stay tuned for those. And I'll open up the floor at this time to anyone who has questions about anything you saw here or anything that you see coming down the pipe. Feel free to either speak up or raise your hand, however you feel most comfortable. We have a question from Benjamin. I guess the natural next question then is, what will change from Ignition Fortress to GZ Fortress? Okay. So we are backporting some of the renaming to Gazebo's, well, formerly Ignition Citadel. Now I'm trying to call it Gazebo Citadel and Fortress. We won't be able to do the same level of backporting from Garden because some of these things do break behavior and ABI changes. So some of the things will remain the same in Fortress regarding the Ignition name, and the same as Citadel. But we are trying to make it as smooth as possible to go from Fortress to Garden. But we're not likely to change Ignition Fortress, for example, the collection package that you install to GZ Fortress, for example. I'm not sure if that answers your question or if you're looking for more clarification on something specific.
Yeah, I think that answers my question. I was just more or less thinking of sort of work process pipeline for people using simulation and competitions and students and stuff, trying to have them use a unified way forward where you don't have stuff such as some autopilot code that we use a lot, like PX4, where we have a bridge that talks directly ignition transport, trying to make that more or less closer to future proof in how it calls things by not having to worry about keeping both like IGN Gazebo launching more or less versus GZ sim launching.
Yeah, we try to make it as easy as possible to migrate from Fortress to Garden. So a lot of the same headers are, we set up the headers so that they can point from Ignition to Garden. So you should be able to migrate a lot of your custom plugins, for example, fairly easily. The command line tools, I believe you should be able to install Ignition and Garden, sorry, Ignition Fortress and Gazebo Garden side by side and not have the tools collide. So migrating scripts should be a matter of changing IGN to GZ, things of that nature.
Okay.
And hopefully we won't change it back again. I'm joking, we're not going to put people through that. Any other questions?
Yeah, I have a question. How did you guys do the sky, the different sky outside of the world and then the sky inside the dome? Is that a skybox or is that like a different sky?
I think Althone can answer that, but I believe it's a texture on the inside of the dome.
Yeah, it's a texture inside.
And the outside one?
I think Ian set that up.
Outside one are basically the sun is a flat plane with a texture on it with emissive properties. Same goes for the stars as well that surrounds the environment. They're all very, very far away, but shining lights a little bit.
I believe the Earth is actually a model.
I think the Earth is a sphere, but it's also very, very far away with a high-burst texture.
Let me see if I can. I was going to try and be tricky and show the Earth up close and then pan into the moon, but you know how things go. Any other questions while this loads? There are also, oh, of course, I'll go into, where's the Earth? There it is. This is exactly how long it takes to go from the Earth to the moon. NASA's lying to you all. All right, well, I spent all that time just to show that. Anyways, I think we're running out of questions. So we'll stop it here, and hopefully we'll see some of you at ROSCON, which is coming up towards the end of October in beautiful Kyoto, Japan. All right, everybody. Thanks for joining, and we'll see you at the next community meeting. Bye, everybody.